So yeah, instead of putting it in the lathe and making a real nice chamfer here, which is good, you want to do that so you don't have a sharp edge that will bend and cause problems with the start of your threads. You look at pretty much anything commercially, unless it's total garbage, it's got some kind of a chamfer around it. Now, even though that chamfer is rough, it will look real smooth and nice once the thread is over the top of it. It won't really be a problem, the fact that it's sort of a rough bevel instead of done on a lathe, because we didn't have any 3-jaws on lathes and it just wasn't worth doing the extra. Another thing which I had forgot about till after I was just mentioning about these going to be galvanized, being as that they're going to galvanize them, the threads will get some of the galvanizing on the thread also. So you actually want the threads looser than normal. So I just adjusted the die to be a little bit looser. We do the first one, we'll test and see if it makes me happy and loose enough. Lots of different ways, different threading machines. This one is a pipe threader. Most pipe threaders will allow you to do bolt sizes also. It's just the dies are not as readily available as for some other things. We could also single point it, but since we had the right dies for this one before we even took the job, do it the easiest way. I open up the die and I first start it and let oil gauge on the front of that. This is the first time that gauge has been used since we've had the machine. Probably a good amount of rattle. If they don't quite make it with their galvanizing on there, they can wire brush across the galvanizing and spread it out a little bit. But yeah, it should work. I close that back down. And then I will position this again at my starting place on the little scale over here, which I am starting at 7. Start it even with the end of the die because there's a little chamfer. You don't quite get all the threads. They're supposed to be 2 3/8 of an inch. So I'm traveling 2 1/2 inches to get the 2 3/8 inch of threads.
Over it when you hammer it?
No, actually, I'm not going to hammer it at all. Oh. We're going to try. You will be the bending force. Are we on already?
Yeah.
Yeah. Okay. Yes. Here's what's going on. You will be the bending force. And again, you were asking about propane. Propane puts out more heat per cubic foot. And this tip is for propane. It will put out a lot more heat than our acetylene tips do. What the acetylene does, and why I use acetylene a lot of times, is most of the time we're cutting with acetylene. Acetylene is hotter. So the point on the acetylene will start a cut sooner, quicker. You're cutting something, you can walk over to it, whack it off. It's a lot handier for junking things, for making, if you have intermittent cuts, it's quicker. If you're cutting solid plate though, or if you're heating stuff up, Propane, just much better, much better. Big, thick material, propane. I used to work at a place where we cut a lot of thick steel, and propane is the answer. Way, way cheaper all the way around and a better job. But the acetylene, if you have quick cuts, it will let you get started because of the hotter point temperature. It will let you get started making a cut quicker. Okay. And that's of value in an awful lot of stuff that we do. Although the price of acetylene is going up to where we may end up doing less and less with propane. We see. We can press it. We can play with it. A little more consistent. I think I'm still short on this side. It should have been a little less sticking out here.
That's hard to fine tune.
It don't take much to make a difference.
Yeah.
We're still on?
Yep.
If we were, now normally when you're doing a U-bolt, you're not using it to the full absolute extent of its strength. If we needed to have a U-bolt that we were extremely strong, we made it out of 4140, we heated it, we bent it, we pressed it, used it, however we did it, even if you bent it cold, you have compromised the ideal structure of what it was. So if you need 100%, which is very seldom with a U-bolt, but if you need 100% of what a piece of alloy steel would do, then you would heat treat this after you were done. But heat treating it after you were done also gets a little sketchy with the threads. And then do we, after we're done, roll the threads? There's just a lot of things. You very seldom need that much quality in a U-bolt. And I mention that because like these are just 1018. The heat treating is irrelevant. But some people got all kinds of freaked out about some other U-bolts we were working on, and nobody knew. Probably not even the manufacturer of the U-bolt, but definitely not us or anybody on YouTube knew what the bolts were made out of. So it was all a guess. More discussion about this. Yes, we were, because when you're doing this, you want the heat, when you're doing this technique, you want the heat to do the bending. What Burke was wanting to do was just pull on the tube, and at first, to start out, he had to feel what it took, how much force it took to bend it. But once he had an idea of how much force, then you try to concentrate being the puller on not using more than that force. You don't want to use less, but you don't want to use more, because if you use more, then the bend can make a little flat spots as it gets ahead of the heat. If you just keep the pressure to bend it down to the level where it bends as the heat makes it bend, allows it to bend with that lower torque, then you can walk it along. And as this is starting to cool down and we're looking at it a little closer, it actually looks like this first test one here is probably too long. So we're probably going to end up keeping this one just as a souvenir for ourselves, and we'll probably cut 2 more of them that will be slightly shorter. A little bit more easier to handle now that it's not 1400 degrees anymore. So we measured this one here for the actual opening, and it's correct. This one was correct. The other one was about 80 thousandths too far apart, so we spread it in. We pressed it slightly. And so now we have 2 U-bolts. And yes, I will admit it's not absolutely perfect on the 2 legs, but there's going to be some tolerance anyway. And they are done. And we just couldn't quite justify the ideal way to do these. If you had a bunch of them to do, is you would make a die that both fit the outside and the inside and just press them. And you can either press them cold or hot. I've done both. But the heat, walking them like we did, was pretty effective as far as the lack of needing extra tooling to do it. It was pretty simple. And world's a happy place. We'll wrap these off and we'll send them off to Ohio. And they'll galvanize them and hopefully they'll love them.